Okay, hello everyone, thank you. So I couldn't come up with an attractive title for this presentation, and I thought the organizers would find it boring and put me in the little rooms, but here we are on the big stage, so thank you for being here this early. So I'm Max. I think we're not mirroring, right? Oh, we are now, okay, great. Okay, so these are a few facts about me, what keeps me busy. I want to give a shout out to the organizers for organizing a daycare for my baby. So I literally could not have been here without that. So yeah, really big thank you. You may know me from River. So I did another PyData talk about online machine learning. I'm going to talk about something completely different today. So I used to work at Allen, a health insurance company. And over there, our CEO, he used to check the numbers every Wednesday. Like he checked the KPIs, for instance, the revenue. And we had the data on call who would help. And the conversation was nice and friendly as long as everything was okay and the numbers were going up. But things can go wrong, and it's interesting, stakeholders ask questions when the numbers don't look good. Like they ask you why. They ask you to dig, and in this case, it could be for several reasons. The spend per customer went down, or the number of customers is down, and it's really tricky situations. Like it's difficult to explain why. And so this creates distrust. And it really made me appreciate how analytics engineering is difficult. Like for me, it's not about do you use DBT or Looker. It's more about the methods that you use, right? And this is really tricky because I think, and I have the impression, and my experience is that there's a lack of formalism. And yeah, in the end, it creates distrust to not provide clear answers. And I actually suspected that the CEO of Allen had his own dashboard that he built himself that he trusted. So not a great situation. And at Carbonfact, where I work, we measure the carbon footprint of fashion brands. It's even worse because the stakeholders are our customers. It's not internal. So our customers always ask us, why did my carbon footprint go up or down year on year? I want you to explain it to me clearly. And yeah, this is tricky. We need to answer these questions every day. It's very time consuming. Yeah, so maybe you know about metric trees. I believe that they're a really good start. So metric trees are a pattern to kind of have your top line KPI at the start. So maybe here it's profit on the slide. And you would break that down by revenue and by cost. And it's kind of a formalism to, build a tree of your KPIs, and they depend on each other, and it's kind of visual. Count is a great tool that kind of is advocating for this, and I think it's great. But I just don't think that it's, the point of this talk is that it's not enough. We can go a bit further than that. So I have this example. My girlfriend works at Airbnb, so I always use this to try to explain it to her. So the revenue of Airbnb is basically the money that has been spent by their customers on bookings. And one way to look at it is to say that the revenue is the number of bookings times the revenue per booking, right? So it's a total number times an average. And so here I have a little data set. So in 2019, you had some bookings and a certain revenue per booking, $200. In 2020, this is a toy example. In 2020, only the revenue per booking went up, okay? And it's a special case. 2021, the revenue per booking was the same, but the number of bookings went up. And then in 2022, there's two effects. The number of bookings went up and the revenue per booking, right? So when you are analyzing this data and reporting on it, the kind of naive way to do things, straightforward, is to just calculate the revenue. So you multiply your bookings per average revenue per booking, and you look year on year, and I can tell you the growth. I can tell you that in 2020, the growth is of $20K. And that's obvious because we know that it's due to the increase in revenue per booking. But in 2022, the increase is of $52,500, right? And we know that it's because the bookings went up and the revenue per booking went up, right? The thing is, so we know that what it's due to, but we can't quantify it, right? It's not straightforward in this table how much is due to each factor. Well, as Michael says, we can do better than that, hopefully. So we do this internally at Carbonfact, and we decided to make a little Python package. It's called I Can Explain. Again, I'm not very good with names, so I tried to make it obvious. And so it's a little package that you give it, the idea is that you give it a table. I'll get back to that, what kind of table. And it kind of decomposes the metric for you. So in this case, our metric is revenue. And instead of just telling you the growth is 20,000 or 52,500, it decomposes it into two effects, right? So the output here is a table of two columns, and there's two effects. So the inner effect is the growth that is due to the increase in revenue per booking, right? It's the average that went up. And then the mix effect is the increase that is due to the higher number of bookings, right? So you see in 2022 that instead of having just 52,000, we have both. We have an inner effect and a mix effect. And the mix effect is higher than the inner effect, meaning that the growth is mostly due to the higher number of bookings. And I think this is fundamentally more interesting to inform your stakeholder than just telling them growth. And just telling them that the revenue, that the average went up and that the number of bookings went up. Because here you can actually you can really tie it and quantify it. And I think that's great. So you may wonder, of course, where these numbers are coming from. So I won't go into too much detail about how this works. I've actually written a couple of blog posts about this. You can find them on my website. But there is a visual geometric interpretation to this. So in green here, you have the revenue in 2021. It is a rectangle. One side is the average revenue, 220, and the other side is the number of bookings. That gives you 330,000. And then the big square is the revenue in 2022, and it is due to two effects, the inner and the mix. In red, you have the inner effect. It is the growth that is due to the higher average, right? So you see that the side there, it goes from 220 in green to 225. And yeah, the math behind is actually just translating this. It sounds dumb, and that's the point, is that this is self-explanatory. It's kind of, if you dig into it, you kind of understand it, and you can explain it. So it's not fancy, but it's just something that is nice to kind of do, basically. So what I just showed is the most basic usage of a more general framework. So the same approach can be used in different ways. So for instance, if you understood the image, you might be wondering that there are different ways to break down the rectangle, right? The red side could have been bigger, and it could have replaced some part of the blue side, or we could have put a purple side at the top right. So there's different ways to break it down, and basically it comes down to interpretation and what you want to do. We can also decompose other metrics. What we just decomposed is a product of an average time a total, but there's other things to do, such as breaking down an average or a funnel, and also a natural direction, and this is where it gets really useful, is to break down the composition by a dimension or several dimensions. That can be really useful. So I'm going to show you that right now. There's this data set that we share in the package. It comes from Carbonfact. It's anonymized data, I hate that word, from a customer of us who has clothes. These clothes are part of categories, and each garment item has like a carbon footprint, CO2. So here you have pants that emit 43 kilograms of CO2 equivalent, and they sell a number of units per year, right? And basically they want to track the average footprint across all their clothes. So, the dumb thing to do, and we do this on their platform, is to tell them, hey, in 2021, this was your footprint, and then it went down in 2022, and then it went up in 2023. That's already great to be able to have these figures, if they're correct. But obviously, the customer asks us, why? Why did it go up? And especially, why did it go up? Yeah. So in 2022, they didn't say anything. They said, oh, great, it went down. And then in 2023, they looked at us and said, why? It must be wrong, right? It must be wrong because I'm using better materials, and I just don't want to believe you. And so this is a different case. We are looking at the we want to decompose an average, which is not a sum like we just did for the Airbnb example. And so the package can also break down an average. And so you have this output table that is also broken down by dimension, so the type of clothing. And what it tells you is interesting. The values are expressed in kilograms of CO2. So we know that this table tells you that in 2022, the average footprint globally, as compared to 2021, went up 0.6 kilograms of CO2 due to the inner effect of pants, meaning that pants were more polluting in 2022. It also went down 0.69 kilograms of CO2 due to the mix effect of jackets, right? So if jackets are a higher emitter, then the fact that we've produced less of them in 2022 has contributed to the average negatively. In this case, it's reduced the average, which is a good thing. So yeah, and we can tell the customer, you know, it's due to pants, it's due to jackets, and we can tell you how much, which I think is great. And it's great because it's better than just telling the customer, hey, your pants went up and your jackets you sold less, because those are hand-wavy statements, right? They're a bit vague. Being able to quantify it is better. So one way to visualize this, if you don't like tables, is with a waterfall chart. So in 2022, the top blue line here, that is the average in 2022, and then at the bottom you have the average in 2023. And these contributions are additive. So if you sum them up, you get the actual difference between 2023 and 2022. Again, a great property of this decomposition method because it's intuitive. It's not like a kind of Shapley effect or anything. It's, although I don't know a lot about that, but it's something that is quite intuitive. The fact that you can just add them up and, you know, group them by, or we can regroup shirts and T-shirts. It's handy. So the last example that I want to show you is funnels. So what we just did is decomposing a total. We also decomposed an average. And you can actually decompose something more interesting, which is a funnel. And when you think about it, a funnel is, so a website funnel here, for those who don't know, is you have events on your website. So an event can be an impression, somebody's looking at something, a click, that they actually commit to clicking on an ad or some kind of form. And then they might be converted, so they might want to add to cart an item, and then they spend, right? They spend money on what they purchased. So you have all these events, and you know, you want to kind of track your total revenue, and what is it due to, like the growth? Is it due to more clicks, to a better click rate? Is it due to more impressions? You know, is it due to different groups, like different continents? How did that change over time? There's like all these questions that you want to kind of ask here. And one way to visualize a funnel is kind of as a product. So you have your impressions that are coming in, and out you have the revenue. And along the way, you're kind of losing customers, right? Some are not clicking, some are not converting, and at the end of the day, some of them are spending more or less money. So it is a product, right? So what I can explain does is that it can decompose a product, right? You can really say that your total revenue is impressions time click rate, time conversion rate, time average spend. And so the kind of straightforward way to, you know, track this, if you ask someone to analyze it, is that you could look at each event and track a KPI a long time. So in 2018, 2019, we can look at number of impressions, we can look at click rate, and we can kind of tell, you know, oh, it's great, I know that the click rate is going up, so that must increase my revenue, right? It's just a hand-wavy statement, and, you know, that can be sufficient. And in this case, you know, revenue is going up, so, you know, not too many questions asked. I do see, though, that, you know, conversion rate went down, and then the average spend also went up, so I'm not sure, like, how each of these events is contributing to the total revenue, but who cares? The total revenue is going up, so, you know, let's not wonder. But is that a sufficient answer? Well, Drake says no, and there's a better solution, we think. So you can output a table with I can explain. The API is the same. I didn't put the code here, but it's simple too. It can tell you the contribution of each event to the total revenue, right? And so what is I think really useful here, and well, I mean, this is still website funnels, it's more or less useful, is that you can express the contribution of each event relative to the output, right? You can express not just did the clicks go up, you can say the clicks went up and they contributed this much to revenue, right? So again, there's a geometric interpretation to this. It's on the blog, so feel free to check it out. What else? So why I believe in this method is because the math is simple. Like the first time, so my boss who worked at Airbnb, he showed it to me. I was like, I mean, duh, it's you can just draw this on a whiteboard. But I was just stumped by how I was not able to find it online. Like if I typed metric decomposition, nothing really came up, or I fell into metric spaces and it meant it wasn't what I was talking about. So it's simple, and I think it's just so simple that we kind of maybe forgot it. So I'm trying to resurrect it, and I hope maybe someone at the conference is going to come up to me and say, duh, I mean, this exists, it's called this. So in that case, maybe I'll just remove the package. But yeah, what's great is that the outputs are easy to unit test. So the contributions, as I said, sum up. Be it decomposing a sum, an average, a funnel, they always just sum up. So it's something that you can show to a business stakeholder. You don't need to say that it's machine learning or AI. You can just say that it's just math. Yeah, and so the approach is generic, and what I find great is that you can use it in different contexts, right? You can use it at Airbnb if you want to understand how you're making money, but we also use it heavily at Carbonfact to understand why the environmental footprint of our fashion brands is going up or down, be it the average footprint or the total footprint, and we can explain to customers if it is due to the weight of their products, if it is due to the materials, if it is due to more or less fabric, and that is really, really useful. Like it's just, it tells them where they need to focus on, and I think this is great. So I discovered this method like a bit over a year ago, and I kind of just wrote a blog post about it to kind of understand it better, and I got a lot of motivation out of writing this blog post because I got feedback. So people sent out emails or commented on the blog post, and it's inspiring because, for instance, at the top right, you have Shao, who comes from Indonesia, and he works at Grab. So Grab is like the Uber Eats in Asia. And he told me, well, we're using this. We actually use this, but we just didn't tell the world about it. And they use this to understand the growth of their portfolio. Alex from Australia just sent me an email a couple of weeks ago saying that he loved the blog post and he's trying to evangelize it at his company, and he was writing a package too, so I told him, hey, I haven't open sourced mine yet, let's maybe collaborate. At the bottom left you have Martin, who worked at Airbnb and who taught me this method, and on the blog he provided more context as to who at Airbnb actually invented this. And I don't know if they're aware, where it comes from. Also, someone I can't remember his name. He comes from Toulouse, and he's trying to. They had these kind of same problems. Like they had these funnels, and they're trying to understand, why the total revenue was going up or down, and it kind of unblocked them. Like now they're trying to implement this in their dashboards and stuff. So this is really motivating, and one of the reasons why I wanted to make a package. In terms of implementation, I wanted to mention some details. What's quite cool is that the package is implemented with IBIS, and IBIS, for those who don't know, is a Python package that kind of is an abstraction on top of data frame libraries. So you write your code in IBIS, and they provide a set of operators, and what that means is that the package can then work with different backends, with pandas, with polars, and especially with SQL. So at Carbonfact, we use a lot of SQL, so it's very important to us. So I initially implemented these methods in SQL at my company. It was hundreds of lines, and I didn't want to maintain them, so I decided to kind of, write it with IBIS and put the burden somewhere else. And so now it's IBIS who has to take care of doing the translation to SQL. And this is really wonderful. It's wonderful in 2024 how when you develop a package, as a developer, you don't need to worry about who is going to consume your package, right? The code I'm writing right now, if we have some kind of new data frame library in 2030, well, if IBIS is still around, they can take care of the translation. And that is really great. Instead of, if I wrote in pandas, it would probably be dead in 3 or 4 years because, I don't know, everyone's using whatnot. I mean, I already feel old. I'm 30 years old and I'm still using pandas and I feel really old. But I love it still. I wanted to use narwhals, but I asked on the Discord, there's no SQL support yet. So for those who don't know, narwhals is a bit more developer-oriented than IBIS. IBIS is maybe more client-facing. But yeah, SQL support is really important to me. I come from the DBT world where you also need to do a lot of SQL and less airflow, less pandas. The cool thing too is that the package is only 400 lines of code. So again, the methods that you just saw are quite simple. And 400 lines of code that work with different backends, I mean, is the dream. Hopefully it's not too much to maintain for me. An example here, so the explanation that comes out of I can explain, you can call the IBIS to SQL, and it's going to spit out all this SQL. And I think there's like 11 intermediate tables. I mean, it's insane. And this is much better than coding it in IBIS and then not having to maintain this. I really think this is wonderful. So the package is open sourced since yesterday. It's on the Carbonfact GitHub, and yeah, it's our second open source package. We're a small company, but we really want to try to take the tech that we develop that is not critical or kind of commercially advantageous, and we want to put it in the open. We really believe in that. I managed to convince my bosses. So the next steps is I really want to make sure people know about it. I mean, maybe that someone will come up to me and say, what you're doing already exists. You haven't invented anything. And I'd like that to happen, because honestly, this is one of the cases where I really want to know what the name of this thing is. So yeah, I have this belief that there's a way to support arbitrary metrics. So right now it's a bit, there's a framework, it supports the mean, the total, the funnel, but I believe there's maybe a way to write down any kind of KPI as a tree and automatically decompose it, right? Because when you think about it, maybe that what is happening here is that we are doing partial derivatives, like with this. So if you express maybe this kind of these KPIs with a DAG, like maybe with a la neural network with PyTorch, then you could auto-diff it and automatically get your decomposition. I haven't tried this yet. I'm not sure about it, but it's interesting to kind of mix the business intelligence world with the auto-diff world and see what happens. So we'll see. It's a space to explore. And yeah, and metric trees are kind of this new sexy thing in the analytics world. It'd be really great if people who built metric trees, they could automatically get these kind of inner and mix effects, and I think that just makes them even more useful. Yeah, interactivity. So I don't know if you know about like Facets, which is from Google, and Vil, which is like an interactive data frame explorer. Being able to kind of, a bit like Minority Report, where you select dimensions and columns, and it would automatically give you the breakdown. That would be just wonderful. Another thing that Martin did at Airbnb is that the outputs of the decomposition, so what I showed you with the clothes, they would pass it through an anomaly detector at Airbnb, and they would kind of spot the top contributors. So maybe that you notice that pants and jackets are outliers, and this can automatically kind of tell stakeholders, you should take a good look at your jackets or your pants, because if a table is quite small, it just immediately pops out. But if you have a dimension with thousands or tens of thousands of values, then it's quite more difficult to spot. So I think chaining the decomposition with anomaly detection could be interesting. And yeah, once this is kind of explored, I'd like to write a research paper about this and maybe educate or motivate a wider audience. We'll see. If you're interested, I wrote 2 blog posts about this. There's also Martin, who wrote a a tutorial on Observable on how to use this to decompose environmental data. And also Xiao from Grab, who wrote how they use this at Grab. Little slide to mention that we are hiring Carbonfact, so we're hiring software engineers and data scientists, data engineers, so it's in Paris, but we're also a remote company, so let me know. And that's it. That was my talk. So thank you, and feel free to reach out or come to see me. Thank you.
Thanks a lot, Max. Any questions? I'm going to start running in the room.
Thanks so much for the great talk. I'm from academia, so I'm ignorant of what the corporate world needs. But from what I've seen, so you're trying to address the why question, which is like very difficult to address because sometimes your variables are collinear and all that. I understand, and in research, this is one of the most important problems, and for that problem we have a myriad of different packages like scikit-learn, SHAP values, and you have Bayesian models with also uncertainty measures, which are also really useful. I think they would be really useful for like anyone in academia or not. And I was just wondering whether like the package that you introduce, which may be very useful for the corporate world, whether it's a bit like reinventing the wheel, because I mean, there's so many tools out there already, like just plain linear models sometimes can explain very well what's going on in the data and like which variable has the largest effect, whatever. And you mentioned it yourself, so how do you feel about that?
Yeah, it's a great question. I was hoping for it. So I have this sensation of reinventing the wheel, but not so much. Why? Because when you use a linear regression or any kind of model and you look at the feature importances, you are building a model and you don't know the world model behind. Like you don't know how that data was generated, right? And so essentially when you do machine learning or any kind of model, you don't know the real model, so you're modeling it, right? In this case, we know the model. Like we know that the average footprint is the weighted product of the weighted average of the product footprints and their units. So there's kind of how to say an immediate mathematical way to do it. You don't need a model. Like you don't need to use a linear regression when you actually know how the metric was built, right? Basically, it's like as if you knew you have your variables, your x's, and you have your y. You know how they depend on each other, so you don't need a model. You don't need a random forest or linear regression. You already know the relationship. And if you start showing Shapley values or a linear regression to a business stakeholder, you lose them. Like in the world I come from, you lose them because if you sum the contributions, they don't always sum up, and if they start asking you where is this coming from, then you are you're on your own. You need to explain it. So if you just explain it to them visually with something that is simpler, then you still keep their trust. And I'm telling you, we managed to convince people who work in marketing departments, in clothing departments, in production departments who have no STEM backgrounds, and they are convinced by this because we kind of tell them it is due to either you've sold more products or your product footprint went up or down. So I get the question, but for me, what I'm doing is simpler in a way because I already know the relationship between the variables and the output. Yeah. It's complementary, I would say.
Yeah, I had a question. Firstly, thank you for the talk, and the topic is very relevant to me because most of my stakeholders are also people from the markets. The question I had is like, in order to decompose a metric, like the business definition should be standard because like in our organization, the organization is so big that a metric like profit contribution to itself has different definitions across teams. So in such a scenario, how can this package, like be a fit for all, or is there some customization that we could apply to this? Because what this package does is really nice, and this is the challenge which I think when I try to implement it.
Yeah, it's a great question. So one of the principles that the package relies on, and I haven't mentioned, is tidy data. So if you have a tidy data set, what Hadley Wickham advocates, it can be fed to the package. I believe that it's a great start to any kind of KPI work. And yeah, what you're mentioning is kind of a human problem of defining things. I think that if you're using DBT and maybe a semantic layer, then it kind of makes you fall in the pit of success because you have to express things with products and sums. And I think metric trees are a good solution too. Like, if you go to a company and say, okay, let's erase everything and define all our KPIs with a metric tree, then it's a path to success, right? Because it allows you to, it forces you in a way to kind of connect all your metrics together and only use certain operators like products and additions, right? And you need some kind of formalism like this if you want to keep control on your KPIs. If you don't do that, then you know, I mean, you have one view here calculating a metric, another one there, they don't have the same source of truth. So yeah, the package is not going to resolve that, but there is this ambition to kind of maybe provide a way to express metric trees in Python and help you do this. But at Carbonfact, it's easy because I invented the whole thing, so I was there from scratch, there was no code. If you work at a big company, then it's more difficult, but I don't have the answer to that.
We have time for one last question, and then we'll break.
Yes, hello. I have a question. If you raise prices, the people who buy or book will decrease. So there is an interaction component between the inner and outer. So how do you propose to take into account that? And I would like to rejoin and challenge you a little bit with my colleagues, because it's important. If you don't have a method that has theoretical guarantees, you could induce your stakeholders into taking bad decisions, and you're going to be blamed for the decision. So I'm sorry, but I have to ask, how do you give theoretical guarantees to your decomposition? Thank you.
Yeah, it's a good question. It's difficult to answer in one line, but in terms of guarantees, the method is provable. So in my blog post, I try to prove where the equations come from. But it's not like a universal, let's just see if Michael. It's not like a universal solution. There's kind of some business sense that you mix in there. Like the fact that you are saying that your revenue is your average spend time the number of bookings at Airbnb, that is a human, it's causal, right? I don't know, it's some kind of human that said that. But once you've said that, it is already your model. Like the fact that you said your revenue is your spend times your bookings, that is your model. Like you've already expressed that it is just a product of these two KPIs. So the guarantees are already there in a way. So I'm just saying that once you've expressed this relationship, the relationship is given to you. It's not like I give you a data set and you need to guess the relationships. It's not the same situation as statistical inference where you're building a model and you don't know. Like in this case, we know the generating process. So it's just not the same problem to solve, if that makes sense. But I get the confusion, so just to finish on that, it's like when you come from statistics, you know, I get it, collinear, I mean, I've been to university, I've done all that, but now I live in a world of business where all that is thrown out the window. Like they don't want to hear about linear models or random forests. They have cold facts. Like my revenue is my spend times my booking. So the solutions just need to be simpler. They would laugh at me if Monday I came with a linear model, but they do like this because it's they like it because they understand it in a way, right? I know it's a pitiful answer, but and I would love to do more complicated things, but this is it.
Thanks a lot. I think we can thank our speaker again.
Thank you.